Okay, well, I think since we have everyone here, we'll go ahead and get this started. I won't keep you here too long because that was quite a long general meeting. We had quite a few announcements. But now that that's over, welcome everyone to the winter quarter intermediate pipeline. If you don't already know, my name is Harper. I am a fourth year stats and data science major, and I'm running the intermediate pipeline this year. If you have just come over from the beginner pipeline from last quarter, then you're definitely in the right place. If you're new to the club, then welcome. This pipeline is going to be sort of, it is called the intermediate pipeline. It's more of a, I guess, beginner project pipeline, if you will, because we're going to go over some of the basics of data science projects, things you can expect, things you'll have to take care of, how to deal with data, things like that. And it's, for the most part, going to be done in Python. So to get started, just a couple of logistical items. If you are completely new to Python and you've never coded in Python before, I highly suggest you hop over to the beginner pipeline, which Luke is running again this quarter. He goes over all the basics of Python, so basic functions, things like that, just if you've never seen it before, because in this, we're going to be going over some things, assuming that you guys have some knowledge of it, right? Project groups are also going on this quarter as well, and that's all in preparation for the project showcase, which happens in spring quarter. So if you are at all interested in doing a project or working with a project group in preparation for that, I definitely recommend you check out the project group meeting that's happening in the main Zoom that we were just in. You can be in the intermediate pipeline and do a project group at the same time if you so wish. And I definitely recommend you check it out if you're at all interested, just because they're still sort of making project groups right now. And now's the time to join if you are interested. So there's that. I will also be recording each of these presentations, so you will always have access to this if you happen to miss a meeting or something, or just wasn't able to make it for whatever reason. I will have recordings of all these, so don't worry about that. Pipelines do restart each quarter. So if you were in the intermediate pipeline last quarter, and I don't think anyone here that is here right now was, but if you were, you don't need to listen to me talk again unless you really just want to be here for whatever reason, because most of the information I'm going over will be similar to what I did last quarter. So not too much new there. Now, there is a Slack channel that I want you guys to join. This isn't the right channel name. This is from last quarter. The one I want you to actually join is the Intermediate Winter 22 channel. If you get a chance, I want you to go to Slack and do that right now, because this is where I'll be putting pretty much all announcements, all material links, everything like that. So definitely join this channel. Okay. And the way you do that is you go to the sidebar in our data science UCSB Slack, and you go to the add channel button, which is kind of over here on the side, and then you browse for the intermediate channel. Okay. If you already joined the one for last year, which should say like fall 21 at the end of it, go ahead and join this new one. And I've already put the links to this presentation, the slide deck, in that channel already. So if you go join that, you'll find all this stuff there. So yeah, like I said before, today's kind of a high level overview of what a data science pipeline looks like. We won't be going into too much depth conceptually or technically about anything just yet, but this is sort of a layout of what the rest of the quarter is going to look like. Normally we go through some of the more basic things, like some data engineering concepts in the beginning, some like data visualization, making graphs, things like that. Learning our way around like pandas and stuff sort of in the beginning, the first couple weeks. And then towards the end, since winter quarter is a little bit longer than fall quarter, I think we have, I want to say 8 lessons in total this quarter, as opposed to the 7 last quarter. We might have a little bit of time at the end to learn about some other concepts, maybe do a little bit of coding in R to if that's of any interest also. We're sort of looking at everything from a very high level today, kind of as if you were standing at the top of a mountain and looking down into the forest. Everything is not too clear yet, but we'll eventually be making our way through and parsing out the details as they come up. So going into data science, there's sort of this question we always have to ask ourselves, and that's, what is it exactly? What is data science? It's very vague and very ill-defined. And that's mostly because it's relatively new, all right? This is sort of a new field that people are just sort of starting to recognize more recently as being very important, not just in the research process, but in developing like applications and tools for real life, real practical use as a whole. In general, we can sort of summarize it with the graphic that you see here. It's a combination of not only computer science and programming, but also like theoretical statistics and domain experience as well. So like business expertise in this case, or like any domain knowledge for the subject at hand, right? Very interdisciplinary subject. The method of carrying out a data science project is very similar to the scientific method. And we've all seen this before. We have some sort of observation about something in the world around us, and we develop questions about it. And from those questions, we sort of develop hypotheses that we want to test, and we run experiments, reevaluate our hypotheses, and then come to some sort of conclusion or result that we can bring out to the world around us in some sort of meaningful way. We'll see this diagram pop up a lot. I bring it up quite frequently throughout this pipeline, and this is just sort of a very high-level overview of the pipeline. So kind of like our scientific method, our data science project follows sort of this path, right? And you'll see here that while we always start sort of with this question or concept or data set, the process isn't entirely linear. A lot of the modeling and exploring and pre-processing of the project can sort of happen cyclically. So we're always going back and revising things, trying to improve our model. And it's not always something we do necessarily in one try, since we always run into problems that maybe we didn't foresee in the beginning. Like I said, we usually start with some sort of question, something about the world that you're uncertain about and want to explore more using data. But oftentimes, especially sort of in the beginning when you're a student and you're just starting out learning data science, we don't always have these questions developed yet, right? Sometimes we just want to start doing something and see where we end up. So like as we'll see later on in the slide deck, we can always start with data as well and just see if any questions develop just from looking through the raw data itself. So what does data look like? I mean, to most of us, I'm sure we've all seen data in some capacity before, and a lot of the time it looks a lot like this. Now, this is what we would call tabular data. It's very neatly organized. Everything's in rows and columns. This is how you would read, this line of code here is how you would read in a CSV file, which is essentially like an Excel file, rows, columns, into your notebook or your code or whatever you're using, right? You'll notice the name of this file was Titanic dataset, and this is because this table specifically is an excerpt from a very famous toy dataset. We'll call it a toy dataset because it's very commonly used as a learning tool for data scientists in training. And it's essentially a long list of passengers that sailed originally on the Titanic, and all the subsequent information about each passenger that's relevant. So you'll see a lot of different features here. Like here you have name of each passenger and all relevant attributes following after. Again, this is tabular data. This you will see being used a lot. It's much more simple to use than some other forms of data that we'll see right here in the next slide. Data is also not always as simple as numbers and rows. Image data is also very important in the world of data science because a lot of data science projects have to do with some sort of image classification or image recognition. We'll talk about what all these terms mean, classification and whatnot further down the line. So image data really is just, think of it as like a matrix of RGB values. So right, color values that when aggregated form an image. Text data is also another form of data, very unstructured, but this is also something that you may factor into a data science project you do in the future. All in all, data is very non-specific. A lot of it depends on whatever domain you're working in, right? Data takes on many different forms. When we're first starting out the project, like I said before, we're always starting with developing questions about the subject at hand. In the case of the Titanic data set that I was just talking about, the goal and the components that we need to conduct this analysis are usually very straightforward. In this case, our goal would be to predict which passengers survive and which do not. Okay, and for the data for this kind of thing, we would look at the data set that we just saw on the screen a few minutes ago, which is essentially a passenger catalog that contains relevant passenger information. And the goal is essentially to take those features of each passenger and try to figure out who survives based on just those features alone. For other applications, developing questions a lot more difficult, so right now we have this worldwide pandemic going on with COVID-19, and there's a lot of ongoing research and data analysis going on to this day regarding this specifically. So in this case, we might have several different goals, right? Maybe we want to develop a model that predicts infection patterns based on data we have right now about people in a certain region, or maybe we want to figure out what kind of hospital capacity we would need to address a rise and fall in pandemic case numbers, right? A data science project, a lot of the time, is about modeling, but that's not always the case. As we'll see with COVID, this one particular COVID tracking tool from Carnegie Mellon University is actually a very interesting API that involves a lot of public health data related specifically to COVID. A data science project isn't always about modeling. A lot of the time it's just about data exploration and visualization. That in itself is a very worthwhile data science project. It's not always about, finding some sort of regression model or fitting some sort of line. A lot of the time visualizing data is also very useful. So developing a tool like this could also be a project idea for anyone who's interested in this kind of stuff, right? Just as a preface to talking about where you can actually get data to use, definitely recommend you guys check out our little workshop on developing a personal project, which is on January 20th, I believe, from I think 7 to 8. They'll probably go over this kind of information about how to obtain data that's of interest to you in a lot more detail, but these are just a couple of different sources that you can use. Kaggle, I want to highlight to you guys, is a particularly useful resource just because with Kaggle, there's not only, users who upload, data files to this website, but it's also quite useful if you want to do like data science competitions. Like there are tons of competitions that happen all the time. One of the first ones you'll recognize here is the Titanic machine learning competition. This is a very, like I said, common one for learning. And overall, I just want to stress that this is a very useful tool for you guys. If you want to do some additional reading, or maybe feel like at some point after doing this intermediate pipeline, you want to do a project, but maybe don't exactly know where to start in terms of your data or your subject. So feel free to check out all the stuff on your own time. Just wanted to bring that up to you guys as being a very useful place to look for data. There are also data sets in built-in libraries. If you guys have done like PSTAT 10, for example, and used R, there are a lot of common data sets that are kind of built into whatever program you're using. I know IRIS is a very common one for R. It's like, you know, flower data that has to do with things like the size of petals and things. You can also scrape data from online sources. That's a little more complex. If you have any knowledge of obtaining data and accumulating that yourself, that's another way to do it as well. There's also like empirical data. So like, for example, you were to, on a normal day, back on campus, you were to stand in front of the library for 2 hours and sample everyone who walked by in a given day and collect data that way. That's also data is collected. So like I said, Kaggle, very useful place. Definitely check it out later if you have time. We'll briefly go over machine learning, and machine learning is not, it's sort of a buzzword. Everyone's probably heard at this point, especially being members of the data science club. It's a very hot topic. But machine learning, all in all, is not necessarily something that has to be a part of your data science project. It just commonly is because it's pretty interesting, very useful for certain different kinds of problems. We'll go over the types of machine learning in the next couple slides, but just a note on machine learning. The idea with machine learning is that there are fundamental relationships between features, and we want to make inferences from that, right? And of course, that's something we as human beings can do just by looking at data and doing research, but with machine learning, we're finding ways of doing that, not only more efficiently, but even more effectively than we as humans would be able to ourselves. So just as an example, if you were to look at a very simple set of data where we have input, we denote as X, and output denoted as Y. If you were to take a quick glance at this small table we have here, you would probably be able to tell that there's a linear correlation between these two. And you would be right. This is essentially a line where for every input, there is an equal measurable change in the output. That's very easy to describe. In a similar scenario, we have now seeing this table here, data that's not very clean. It's not as easy to tell what exactly the relationship between X and Y is just taking a glance at the second table. But if we were to plot this using whatever software we happen to be using, we'll see that the correlation is roughly similar to what we saw before. There's still a very linear relationship between our input X and our output Y. But this is something we wouldn't necessarily know about unless we used data science and tools of analysis to sort of tell that to us, right? Almost all data that you will encounter will be noisy in this respect. It won't follow trends exactly. But our job is to find identifiable trends despite the noise that exists in natural data. Main types of machine learning, we will go over each of these types in greater detail further down the line in future weeks of this pipeline. But as a general overview, there are two different types of machine learning, or at least two major camps I want you all to be concerned with. One is supervised learning, which is composed of primarily regression and classification problems. And then there is also unsupervised learning. And we'll go over clustering, which is a type of unsupervised learning in future weeks. Regression has to do essentially with continuous values, right? So in the case here, say we had a bunch of housing data or something. We wanted to figure out how expensive a house would be based on the square footage of that house. And we came up with a plot that looked like this. We might be able to attribute a sort of line to this. Kind of like in what we saw in the example before. Using the data that we have, we create a model that maps square footage of an input value to the price, which is effectively our output value. Classification is a little bit different in that our result or our label isn't necessarily continuous. In this case, based on a couple of different factors about people, we could say collect from a group of people, two different aspects about them as a person. We could collect how many hours they spend on social media per week. We could also take from them, say, how far they live from school. So like we had a data set full of not only students, but faculty members, and we took these two pieces of information from every single one of them. We could, from those two pieces alone, tell who was a student and who was a faculty member, right? In this case, maybe we noticed that students in general spend more hours on social media per week, but in general also live closer to school. Individuals that had fewer hours spent on social media per week, but lived further away from campus, were more likely to be faculty, right? And this is a classification problem because the label students versus faculty is not a continuous value, right? Like unlike price, it's not something that's necessarily continuous, it's one or the other. Unsupervised learning is similar. The only caveat here is that our data set is not labeled, and we'll go over what exactly that means later on, but essentially in an unsupervised learning problem, most of the time we're just trying to cluster things together, right? Put things in groups based on similar qualities. Probably the most simple example of this kind of problem is news articles, right? So if you ever go to if you ever were to look through a news site or some sort of page like this, which is Google News, you'll see that articles are often sorted based on a general topic. So things like news articles related to business will be under one category. News articles related to entertainment or sports will be in another, right? Say we were given a data set that just consists of articles with no labels associated with them. We don't know what their topic is or what their category is. We just have all the words that that article contains. We could use data science to try to figure out what kinds of topics to classify those as, despite not even having a label for them. On the right, this is sort of what a general cluster plot would look like. We'll go over things like k-means clustering later on in the pipeline. We'll talk more about train test splitting and preparing your tabular data set later on, but just so you have this in your head now, I want to bring up the concept of train test splitting. If any of you have ever heard of this, it's essentially a way of partitioning a single data set into multiple groups that we can use for different purposes, right? Most commonly, we'll split a data set into a train and a test group. Sometimes we'll also do this thing called cross-validation. And validating our training set allows us to make adjustments to our model before finally testing it on our holdout group test set. We'll go over why that's important later on, but just something to think about for now. Train test split is usually one of the first steps once we have a usable data set. And we're sort of getting to the end of my general explanation of what the intermediate pipeline kind of looks like, but just for your knowledge, data science at UCSB, there's a lot of different classes, resources we have here. For learning data science, if you want to incorporate it more so into your curriculum, Computer Science 5A and B are relatively new introductory classes, which are adapted from Berkeley's Data 8, which is another data science class. So that's sort of, if you're interested in doing that and haven't done it already, Computer Science 5A and B are some classes you might be interested in taking. If you are a PSTAT student, things you might be interested in include PSTAT 100, which is another sort of introductory but upper division this time, data science concepts and analysis class, taught by some pretty great faculty. And for everyone here, if you are interested in doing the data science capstone, which is now in its second year of being run, this is coded as PSTAT 197A through C. It's also cross-listed as Computer Science 190. This is essentially a year-long class where, under the guidance of faculty, you work with a group of other students on a year-long data science project, right? And this also could count for your major if you're a PSTAT student, for example. And this is open to really all majors. It's not just something for PSTAT students, but I'm currently doing it now. I think it's very interesting. You get to work with not only industry sponsors, but sponsors from UCSB research labs as well. So if this is something that appeals to you, definitely think about this. I will remind you throughout the quarter. There's also a fellowship associated with it. If you're interested, the links will all be in the slide deck that is already posted in the Slack. Like I said, all links will be posted in the Slack channel. This is also just here. The notebooks were created by Connor Levinson, our previous intermediate pipeline leader. And he created these sort of notebooks, which you can open in Google Colab, which is a Python editor through Google. These are sort of supplementary code materials for you to look through that are sort of loosely related to the lessons each week. There will generally be a notebook for every week. You don't necessarily have to do it, but it is of my firm belief that you learn the best by seeing the code yourself. So this is something I would highly encourage you to at least take a look at. I ran into this problem last quarter. A lot of students didn't know how to open Google Colab. Like I said, this is a Python editor through Google. It's a lot like Jupyter Lab, if you've ever used it. And if you have problems with this, let me know and I can help you figure out how to open these. You're also free to download these notebook files yourself and open them up on Jupyter Lab or Jupyter Hub if you have that installed on your system already. And that brings me to the end of my introductory slides for this week. Next week, we will be going over some basic visualization principles in Python, so namely using Altair and Matplot. What I want you guys to do for next week, if you are coming back next week, is to, one, create a GitHub account if you have not done so already. This will be very useful to you further down the line. With future projects, as well as if you have certain classes that involve projects, please do that if you have not done so already. And also familiarize yourself with either Google Colab or install some sort of Python editor onto your computer. I assume a lot of you already have done that, especially if you have come from Luke's pipeline last quarter. But if you have not, definitely take a look at Jupyter Hub or Jupyter Lab, whichever. I will also post an installation guide to Anaconda, which is another way to launch Jupyter Hub in the Slack channel. Okay. And that's all the information I have for you guys this week. I hope to see you come out again next week. We will be doing the same thing. Everyone will join the main data science general meeting, and then we'll branch off into different pipelines after that. Okay. Generally, what I'll do every week is, after I sort of go through this presentation or show whatever code I'm going to show for the week, I will stick around in the Zoom call for however long people still want to, hang around and ask questions. If you have questions about any of the material we go over, feel free to ask me after each of the presentations, I'll stick around. You can also ask me about anything else related to the club if you have any other questions, not necessarily related to the pipeline, data science, other data topics in data science career questions, things like that. If you're a PSTAT student and you have advisory questions, I am actually a peer advisor with the PSTAT department. If you have any questions related to your classes, definitely feel free to ask me as well. And with that, I will let you guys go for this week. Thanks for coming out, and I hope to see you guys all next week as well.
Thank you.
Yeah, of course.